Welcome, everybody, and hello to the fourth NUTRI-KNOW webinar on processing technologies for nutrient management. My name is Daniel. I'm from the European Science Communication Institute in Germany, and I'm the communication officer for the NUTRI-KNOW project. I have the pleasure of hosting this webinar today, and that means I will have a look at all the questions you ask. I will monitor the chat and the Q&A tool, so free to use this, and then I will ask your questions at an appropriate time. You can also use, of course, the raise hand tool if you want to ask your question verbally. That's no problem. Importantly, so today we have around 45 minutes of content planned and then 15 minutes for questions. But if you have any unanswered questions after this webinar, we have created a community of practice for the NUTRI-KNOW project. This is an online forum where you can just register very easily, and it's very easy to use, looks very nice, and there you can browse questions, you can ask your own questions, and then we have all of our experts, farmers practitioners that will be able to answer your questions. You can engage in dialogue, so you are invited to join there. It's completely free of charge. And maybe one last note, this webinar will be recorded and the slides will also be made available probably tomorrow or maybe even today. So we often get this question, so now you know. And with that, I would like to give over to the first speaker of today, which is Celine.
Thank you,
Daniel.
Feel
free to take control.
Yeah. Okay. Firstly, apologize for my camera that is not working, but I'm here. So yes. So I'm Celine from Biogas E. Biogas E is the knowledge center for biogas in the Flemish region in Belgium. And there we form the bridge between policymakers, research, and all kinds of stakeholders, including farmers. And in the frame of the European project NUTRI-KNOW, we organize these webinar series on sustainable nutrient management, thereby focusing on the different value chain steps. And 3 webinars have already finished, as you can see. And after today, 3 other webinars will come. You can still register via the NUTRI-KNOW website. And today we will talk about different processing technologies. So what's the relevance of processing technologies in agriculture? Well, the restrictions on nutrient application on the fields, combined with the presence of intensive livestock, nutrient scarcity, and volatile prices for fossil-based mineral fertilizers, drive farmers to invest in technologies to manage their nutrients. Processing technologies mainly refer to technologies used to process agricultural products to better quality or to treat agricultural waste for fertilizer production, energy generation, or to mitigate their environmental impact. Examples of such technologies include anaerobic digestion, composting, solid-liquid separation, thermal drying, incineration, and nitrification, denitrification. So the NUTRI-KNOW project entails 8 processing technologies related to nutrient management. However, due to limited time, we will only discuss 5 of them, leaving some time for questions. So first, the University of Vic will give an introduction of the slurry concentrator, which separates manure into nutrient-rich and low nutrient fractions. This will be rather short since the slurry concentrator was already discussed in one of the previous webinars. Next, Ghent University will talk about recovery of ammonium salts from manure through stripping and scrubbing. Then CRPA from Italy will present a farm-scale prototype for recovering struvite from agricultural digestate. Then Inagro from Belgium will present the pocket digestion or on-farm digestion of manure for biogas production. And last but not least, Figask will talk about the innovative use of grass in a circular economy approach. The other technologies that will not be discussed in this webinar are digestate microfiltration to make it sustainable for injection and fertigation instead of using mineral fertilizers, nitrogen recovery from ammonia emissions into ammonium sulfate fertilizer, which can replace synthetic fertilizers and reduce greenhouse gas emissions, and the production of nutrient-rich grass juice for algae cultivation as an alternative animal feed. But no worries, you can learn more about all these techniques via our NUTRI-KNOW booklet on processing technologies, as you can see on this slide. This can be accessed via the link on the slide or take a look at our NUTRI-KNOW project website. So then I will give the floor to the other speakers, starting with University of Vic. So Anna, you can take over control.
Thank you, Celine, for your introduction. Well, I'm Anna from UVic, from Better Technological Center, and today I will present a slurry concentrator that is a processing technology for a slurry. That's the fact that managing livestock manure is a big challenge for farmers in Europe, as you can see, both environmentally and economically. So it's a tricky balance because in areas with a lot of livestock and excess nutrients, the pressure on the environment is really high. And that's why it's so important for us to develop, test, and also roll out new or innovative technologies that can help reduce this impact. So we need solutions that make a real difference, and especially in regions where this issue is more intense. So let me talk about the slurry concentrator and how it can help with more efficient manure management. Basically, this slurry concentrator allows us to separate manure into two parts: a semi-liquid concentrated phase, which is rich in organic matter and nutrients, and a liquid phase or diluted fraction, which has a lower nutrient concentration. And what's really interesting is that it concentrates about 90% of the solids, 50% of the nitrogen, and 90% of the phosphorus in the raw slurry. And importantly, it reduces the total volume by 20–30%. And now, why does this matter? Well, the concentrated fraction is perfect for transporting to areas further away because it's smaller in volume, but still packed with nutrients. This reduces transport cost and makes it more feasible to move these nutrients to areas that can actually use them without causing environmental harm. Meanwhile, the liquid part, the diluted part, which has fewer nutrients, can be applied to field closer by where there is a surplus of nutrients. And how it works. So imagine you have a slurry pond that's where the main technology gets set up. The concentrator floats right on the top, thanks to a few devices that keep it balanced and positioned just right on the surface. And now, because this concentrator separates out diluted slurry, we actually need a second pond nearby. This additional pond will collect the diluted slurry that comes out of the concentrator. The rest of the equipment is set up right between these two ponds, and we connect them with a pipe that carries the diluted slurry over that second pond. So in short, it's a simple two-pond setup that allows us to separate and manage the slurry effectively. And the main requirement, which may not always be available, is that two separate pits or ponds are needed to store the two liquid fractions produced. But one of the benefits is that the equipment used to manage the two resulted fractions is the same, consisting of a tractor with a pump and a slurry tanker. This reduces investment cost, but also the operating cost. And also, it's easier to monitor the nutrients applied to the soil, as there are devices that can monitor the nutrient content of the liquid fraction online. allowing thus this precision fertilization and avoiding nutrient losses and emissions. So very briefly, this system, this slurry concentrator, creates two types of slurry. One, a nutrient-rich semi-liquid phase that can be transported to fields in need of nutrients, and the other, a low nutrient liquid for nearby fields with excess nutrients. This setup cuts down the transport cost and applies nutrients exactly where they are needed. On top of that, using the same equipment for both phases means lower cost and less management time. And since this device is mobile, it can easily be shared among farms or cooperatives. And finally, it allows for precise monitoring of nutrients applied to fields, helping reduce waste, cut emissions, and improve soil health. And the current status of this operational group is that we have developed a new business model where the mobile equipment could handle a slurry pit in just a few days, making it a great share investment for several farmers. And this process gave us valuable insights into how to adapt the equipment to different farm needs. And in fact, with so much enthusiasm, the cooperative applied for a national patent. So if you are considering or if you are interested in this technology, the cooperative Plana de Vic offers a free simulation of how the slurry concentrator could work on your farm. And that's all for the slurry concentrator. Thank you.
Thank you, Anna. So here is Hong Zheng from Ghent University. Ghent University is located in Belgium. So as Anna already mentioned, in this Flanders, it's also animal livestock in intensive region has the problem of animal manure. Although animal manure and the derivatives can be used as alternative fertilizer source, but the generated amount cannot be consumed by the local croplands due to the restrictions in nitrate directive. So in the meantime, the farmers need to apply extra synthetic fertilizer. But yeah, the increasing price of this fertilizer become an issue to farmers, especially during these years. So the manure can also be used in a raw way or in a processed way. There are so many technologies to process manure into more efficient and easy applied products, such as the compost or separated solid liquid fractions, struvite, and here the ammonium salts that we will focus in this case study. Unfortunately, this type of products, even though they already proven to be more efficient, they still need to follow the same restrictions as manure products. That means only 170 kilogram nitrogen per hectare per year can be applied. To this end, a renewed criteria was proposed by Gerent's Research Center to promote the circularity of recovered nitrogen from manure. To be used as an alternative fertilizer above the 170 kilogram nitrogen per hectare limit, these products need to meet the requirements. Either it's 90% of nitrogen being mineral, or they have an organic nitrogen carbon to nitrogen ratio lower than 3. Meanwhile, they need to meet the requirements of fertilizing products regulation. That's yeah.
Okay, while Hong Zheng is clarifying some issues, I see that there's first of all there's So are there any participants except Henry that have trouble seeing the slides? For me, it all works perfectly. If there are more, then it would be good to know. And if not, so I suppose that it's only you, Henry, that has the problem. And I hope it will be resolved. And then I think there's also a question, I believe it was for Anna, by Darwin. So if I'm not mistaken, this question is for you. For what size of farms would solution be applicable? I think the slurry concentrator, in terms of maybe even cubic meters.
Yeah, specifically the OG slurry concentrator is think about for a small medium sized farms. Because the thinking behind this technology is that can be a solution shared among practitioners and different farms and cooperatives. So in order to share the investment and also the solution, and so it's addressed to a small to medium sized farms.
Okay, thanks, Anna, and back to you, Hong Sen.
Yeah, apologies for this inconvenience. Well, so we continue with the renewal criteria. Like I said, they also need to meet the requirements in the fertilizing product regulation. So the zinc and copper contents cannot exceed 300 milligram kilogram or 800 milligram per kilogram. And in the meantime, we have to apply these products in a more sustainable way to limit the nutrient losses and ammonia emissions. And here is the principle of stripping and scrubbing process. So the principle lies on the equilibrium of between ammonia, that's NOH3, and ammonia, NH4. So at a higher temperature and pH value, the equilibrium between these two components move towards the right side of the figure, as you see here, meaning that more ammonia is converted into ammonium in a gaseous format. So in the stripping scrubbing process, we have two compartments. The first compartment, we use air to blow the ammonia from the liquid fraction, and then in the second compartment, sulfuric acid and nitric acid are used to recover this ammonia into ammonium sulfate or ammonium nitrate. And then, so based on the acid we used in the second compartment, we have different ammonium salts recovered. Here we have ammonium sulfate and ammonium nitrate. Both of them are pure mineral fertilizers without organic particles. And the pH is 5 to 7. That means slightly acidic. And the nitrogen content is like 8 to 15% of nitrogen. Ammonium nitrate has a higher content of nitrogen because ammonium sulfate also contains sulfur. So these products, they are pure liquid, so they can be injected to soil to reduce the ammonium emissions during application. And in this operational group, we have conducted 5 field trials in 2022 and 2023 with potatoes, maize, and winter wheat. The results indicate that the ammonium nitrate recovered from manure can perform equally as artificial fertilizers such as urea, calcium ammonium nitrates in terms of effectiveness and fertilizing value. Besides, to promote the ammonium stripper in the farm, we also calculate the best cost benefits assessments So there are 4 main factors that's affecting the economic viability of this installation. First is manure type, so it determines the amount of nitrogen present in the manure to be treated, and also what's the ratio of mineral nitrogen that can be recovered through this process. The existing treatment pathways, such as anaerobic digesters or nitrification, denitrification process, can have an added value to this installation, while the scale of the farm and the manure pressure in that region is also very important, because, for example, the implementation of renewal criteria in that region can help to reduce the pressure and also the cost to implement this kind of knowledge. So as calculated, the desired economic scale of applying this technology in the farm is that a farm can produce approximately 20,000 tons of manure per year, and it costs around 100 to 150 euro per ton of manure. That's according to the numbers in June 2023. What's the status of the renewal criteria now? So the legislative status of renewal is still under discussion. NUTRI-KNOW project also contributes to submit a joint feedback on the nature directive evaluation with other European projects. This joint feedback highlighted that the renewal criterion should be intake to the regulations, and we should adapt the legal status of ammonium salts as an alternative fertilizer. So you can also find more information from the NUTRI-KNOW project website, and I'm happy to receive any questions. So I will hand over to the next speaker.
Thanks, Onzen. I'm Giuseppe Moscatelli from CRPA, Research Center on Animal Production, based in Emilia-Romagna region in the north of Italy. Now will be illustrated a digestate treatment technology designed and implemented by Struvite Operational Group. The problems the Struvite Operational Group wants to answer are the high P content in pig livestock farm soil, the ammonia emissions from digestate storage and application, and the nitrate surplus in those areas characterized by high livestock density. To do this, the operational group designed a prototype at farm scale for extracting struvite. Struvite is a salt of ammonium magnesium phosphate. So the main goals of the activity were to decrease nitrogen and phosphorus content in pig livestock digestate, to reduce emissions from storage and the spreading phase, and to facilitate the soil application of the treated fraction depleted in nutrients, and at the same time recovering nitrogen and phosphorus as fertilizers matrix for replacing chemical fertilizers in the nutrient deficient area. The struvite prototype plant was installed after the biogas plant of a pig livestock. The name of the pig livestock is Colombaro Farm in Modena, in the Emilia-Romagna region, and treats the digested clarified liquid fraction produced by screw press solid liquid separation. The digestate is an interesting matrix to be treated by this process and to produce struvite because anaerobic digestion mineralized a quote of organic phosphorus and nitrogen into orthophosphoric and ammonia nitrogen. These two forms are usable to produce struvite. This is the layout of the treatment. The digestate clarified is the digestate clarified liquid fraction from the solid liquid separation is first slightly acidified to decrease the pH from 8.5 to 7.5. In this way, is increasing the mineral orthophosphoric P form. After this acidified fraction is microfiltered at 40 microns to partially remove the suspended solid and organic matter that hinder the struvite crystallization. The microfiltrate fraction is then loaded to struvite reactor, where crystallization and precipitation of struvite take place. The struvite reactor is composed by two concentrical cylinders. In the internal cylinder is added magnesium chloride to facilitate crystal development. In the external cylinder is added a base to increase pH from 7.5 to 10 to promote the struvite precipitation. The surnatant treated fraction exits the reactor on the upper surface, while the precipitate with struvite inside is discharged every 8 hours from the bottom of this reactor. This one is the figure, the image of the prototype installed in the pig livestock farm. This is the pre-treatment acidification tank. This one on the left is the microfiltration equipment. And on the right side of the figure, we can see the crystallization and the precipitation reactor. The treatment efficiency are in average good. The P content in struvite precipitate is 6 times higher compared to P content of the microfiltrate fraction that enters in the crystallization precipitation struvite reactors. The prototype treatment, considering both the microfiltration steps and the struvite reactor steps, reduce by 73% the P content in the surnatant treated digestate compared to the input clarified digestate fraction. The nitrogen is reduced by 20%. The 37% of the influent P is recovered in the thickened fraction produced by the microfiltration equipment, while the 24% of the influent P is recovered in the struvite precipitate. But if we consider between in and out in the struvite reactor steps, the 61% of the phosphorus that enters with the microfiltrate fraction in the struvite reactor is recovered in this struvite precipitated matrix. To conclude, the struvite system applied to the livestock digestate to recover phosphorus and nitrogen are technically feasible, but this treatment has still to be further more efficient in the cost and also in the management efficiency. The precipitate containing struvite should be used as raw material for the production of phosphate fertilizers to replace phosphate rocks by the fertilizers producer. Technologies for nutrient recovery also allow to reduce emissions, and at the end, unluckily, the high concentration of solid in the digestate, even if subjected to solid-liquid separation and also microfiltration, is a critical problem for this kind of technology. Now I have concluded and leave the control to Celine.
And I think Ines is next. And while you are taking control, we have one question by Rachel. I think this goes to you, Hongzhen. It's about the sulfuric and nitric acid and about their price. Not sure I understand the question completely, but are they the same price, or is one cheaper than the other?
According to manure, yes, indeed, there are differences in the price, and usually sulfuric acid could be a little bit cheaper. But yeah, it also depends on different region and market demands. So, but when you decide the sulfuric acid or nitric acid to use, it's also depending by the end or the resulted products, what's the nitrogen concentration, and eventually if your crop needs sulfur for this if we resulted in ammonium sulfates as the end product.
Thanks, Hongzhen. I just have to re-upload the slides again. I think they just crashed, but no problem. They should be up now. There's a question by Darwin. Well, the suggestion is to ask this question at the end, but maybe we can already ask it now. A treatment is. Do you know, maybe all who presented already, Giuseppe, Anna, Hongzhen, about a treatment price per cubic meter? Do we have estimates or numbers on that?
Regarding to the struvite prototype, being this a prototype, at the moment is not possible to have the cost for the cubic meter, because, for example, every month we implemented this prototype. And the project is running also in the 2025, and we hope in a stable management, and so we can derive the operational cost.
Maybe the other speakers want to,
Yeah, sorry, it's Anna from UVic about the slurry concentrator. Same as Giuseppe, it's difficult to give an exact price, as it will depend on the performance of the technology. I mean, if you, I can give you numbers about the investment cost, for example, on the price of the concentrator, but then depending on the performance of if you share this solution among different farmers, or maybe a cooperative, the price, well, it will depend on these conditions. But yeah, I will ask to Cooperative Planeta Big that has the technology for this investment cost, this initial cost, and then I come back with the exact price. Maybe using our community of practice, I can provide there the answer. Thank you.
There's one question directly to you, Giuseppe, and then I will give over to you, Ines, I promise. There's a question again by Rachel: why not lower the pH in the struvite production to 5 for more phosphorus releasing into the liquid phase?
it is very correct. In the laboratory experimental case, it is possible, but in this livestock farm, we treated digestate from pig livestock, and also in the diet of the digester, there are also a quote of dairy co-manure. And if we decrease the pH under 7, we create a lot of formation, the foam. And this foam after is translated in the struvite reactor and give us a problem. And so we stop at pH 7.5.
Thanks, Giuseppe. And I now give over to Ines.
Yes, thank you. So imagine a sunny, windy day in summer. During those days, Europe will produce a lot of renewable energy through solar and wind power. But what about the dark, cloudy days in winter? Well, then we have anaerobic digestion, because that technique produces renewable energy out of biomass. And so, because biomass is readily available, we are no longer reliable on the weather, and we are able to produce quite constantly the renewable energy, both heat and electricity. So what is anaerobic digestion? We always compare it a bit to a dairy cow, because you feed it and the microorganisms inside give you gas and manure. So that's also a bit how the anaerobic digester works. You feed it biomass, which can be either liquid or solid biomass. So liquid biomass can be pig slurry, cattle slurry. Solid biomass can be the solid fraction of manure or agriculture residues. And you feed it to the digester. So it comes in the reactor, which can then be compared to the stomach of the installation. And that is where the microorganisms are, and those feed off the biomass and in the process produce biogas. Now, just like with us, we don't take in all of our calories of one day at once. So you also feed the biogas installation multiple times a day. And when the biogas is being produced, it is temporarily stored within the membrane on top of the reactor. And from there, the biogas is then transported to the CHP, the coupled heat and power unit. And that is where the biogas is being burned. Now, biogas can consist out of 50–75% of methane, which is the energy containing factor, the part of biogas that we want the most. The other 25–50% is mostly CO2, and a very small part is like water vapor or H2S. So the biogas is burned in the engine of the coupled heat and power unit, and that drives a generator which produces electricity, and also the process itself produces heat. So a small part of the heat and electricity is used for the installation itself. So electricity for all the pumping of the feedstock, of the mixing of the reactor, so that the microorganisms inside can get to all the feedstock very nicely. And the heat is used to keep the reactor at a constant temperature, because the microorganisms also have an optimal temperature at which they thrive and reproduce. And for most of the installations, this will be the mesophilic temperature range, which is around 38 to 42 degrees Celsius. But all of the other heat, all of the other electricity is then available to use on the farm. And because we also keep the volume of the reactor quite constant, before something is being pumped in, there's also a part that is being pumped out. So this is the digested biomass and is now called the digestate. and this can go to an external storage. That is a bit how anaerobic digestion in general works, but what now is the difference with farm scale anaerobic digestion? So in comparison to the large scale installations, farm scale anaerobic digestion only uses the proprietary biomass, so what is available at the farm itself. So most of the farms will just use either their manure or agriculture residues. Nothing is being transported to the farm, nothing is being bought to use in the anaerobic digestion. The coupled heat and power unit can go up to an electrical power of about 200 kilowatts. So compared to large scale installations, this can be around 1 megawatt. So you see the difference, it's much smaller. For that type of installation, most of the time up to 5,000 tons of biomass will be used per year. And you either have the choice to have co-digestion or monodigestion, which means for monodigestion, you focus on either manure or agriculture residues. For co-digestion, you can add both. Just keep in mind that for legislation, as soon as one drop of manure goes into the digester, all the digestate is seen as animal manure, animal nitrogen, and so also agricultural residues, so vegetable nitrogen or plant-based nitrogen will be transformed to animal nitrogen. So especially for our region, Flanders, where we are limited in the amount of nitrogen we can use, and we already have a lot of animal manure available, this is not something that is wanted on the farm itself. So that is why most installations here in Flanders will just use manure. And also taking into account one of the previous questions, for the smallest installation, which will be around 10 kilowatts, so the electrical power of the CHP, can start from about 60 dairy cows, to know for which scale we are thinking. So that's the process. Then what do we do with the digestate? So the digestate is the digested biomass. It is still a perfect fertilizer to use as such, or to also process even further. Just keep in mind that the digestate will be about 30% lower in dry matter and organic matter. For the nutrients and P and K, normally they remain quite the same, except for nitrogen. The ratio of mineral nitrogen to total nitrogen will be higher. So there will be about 20% more of mineral nitrogen in digestate compared to the raw slurry that would go in. So this is something to take into account when you use digestate instead of raw animal slurry, because 20% of the mineral nitrogen, or the nitrogen in total, will be more immediately available, and then the nitrogen that is still bound to organic matter will be available later, so around, if you use it in spring, around autumn. So this is something to take into account when using it. That's why we always say use the 4R principle. So use the right type of fertilizer for the right crop. So if you have a crop that you can use nitrogen both in spring as well as in autumn, it's perfect to use. Or if you have a short crop followed by a cover crop, this can also be perfect for the nitrogen uptake in autumn. Also use it at the right time, so apply it just before sowing or planting, so that the nitrogen that is immediately available won't be leached out. Use it in the right dose compared to the fertilization advice, and use it with the right method. The digestate might be a slightly bit higher in pH than the raw slurry, so there might be a little bit more emissions. So also when applying it to the field, try to use a low emission technique. But why invest in the farm scale anaerobic digestion? because, as I mentioned, it can help a farm to be more self-sufficient in energy, both in electricity as well as in heat. And compared to solar panels or a wind turbine, it can produce renewable energy quite continuously. Now, to get the most biogas out of the manure or the agricultural residues, you need to digest it as soon as possible. So for manure, you get it to the digester as fast as possible. It spends less time in the animal housing, so there will be less emissions there. So you reduce also the amount of greenhouse gas emissions on a farm scale. As I mentioned before, because of the higher mineral nitrogen content, the fertilization value of digestate goes up. And depending on the farm, depending on the region as well, it can be a very profitable investment. But this is highly dependent on regions, on subsidies, on the technology provider, and what they ask as an investment cost, and sometimes also for an operational contract that they provide some of the operational work for you. So these are the pros. What are the cons? As I mentioned, it can be compared to a dairy cow, so it also requires a little bit of daily monitoring because you work with living microorganisms. This is around 15 minutes to maximum half an hour a day, so it's not too bad. But to get the certificates, to get everything up and running and subsidies, it is a little bit of administrative work as well to get all that sorted. When in 2011 the technology rolled out here in Flanders, there were also some problems at the start, so the technology also suffered a bit in their image, but this has gotten a lot better across the years. And also, for the case of Flanders, Belgium, at this moment it is quite difficult also to get a permit, so sometimes the legislative framework also matters. But in the years, we have had several operational groups where we try to get all the farmers with a farm scale anaerobic digestion together, where we learn from each other, where we try to up the performance. And because of that, we have seen that in the last couple of years, there is an increase in installations again. So hopefully we can continue this positive trend in the future. Thank you.
Thank you, Ines. And before John embraces himself for the last input today, maybe also the question to you, would you be able to say anything about initial investment, operating costs, that sort of thing for the farm scale digesters?
Yeah, so it depends a lot on the scale that you would be able to put on your farm. So as I mentioned before, the smallest installation, which has a CHP of 10 kilowatts, here in Flanders, I know that this technology can be available for starting from around 150,000 euros. And the operational costs, if you have the contract with the technology provider, starts also from around 1,000 euros per year. But depending on the incomes you get out of it, so the electricity costs that you avoid, sometimes also gas, because you can use the heat to heat your water and everything. The subsidies, it can be a profitable investment. But those are the investment costs and the operational costs.
Thanks. So John, feel free to take control now and take the full 10 minutes. I would say if there are remaining questions at the very end, we will go 5 minutes over time.
Thanks very much, Daniel. Good morning, everybody. My name is John Hendrick, and I work with Teagasc in Ireland. And today I'm going to talk about an operating group that was in the southwest of Ireland, and that was biorefinery Glas. It's a pilot scale operation of refining biomass, but in this case it was grass. There's been a number of different iterations of these pilots. Biorefinery Glas is the third. So essentially it's scale. The first was just to see would it work. The second was processing 1 ton an hour, 1 ton per hour of fresh grass. This biorefinery in Ireland was processing 2 tons of biomass per hour, and since this there's been another refinery in Holland that's processed 4, but the ultimate aim getting to 8 where it's scalable for production. So what is the biorefinery process when it comes to the biomass that is grass? So it processes grass into 4 products, and it's doing this, it's refining unused protein that is not used normally by ruminants when they eat the grass, whether that is fresh grass, which is brought in a zero grazer, or grass that is ensiled into silage for use at a later date. And let me see, 50% of the weight of the fresh grass goes into a press cake. Now this is it's the solid part of the grass, and this is what's still going to be fed to the ruminants. All of the nutritional value that the ruminants want remain in the grass, but there's parts in what comes out in the juice is the liquid that contains the nutrients and the proteins that cows or ruminants don't process. I'm just going to call them cows because it's just easier, it's more natural for me to say it. But by doing this, you're going to increase the usable protein per hectare by 40% that you can get. And you're going to reduce your nitrogen and phosphorus losses by 25% per hectare. And what's the reasoning behind this? Yes, it's an economic thing. It's more efficient use of resources. But in Europe at the moment, the amount of protein that we're using is in excess of what we can produce. There's going to be a scarcity of protein. So it's the real motivation behind the biorefinery for biomass, particularly grass, is trying to be more efficient use and producers of protein. So that extra 40% of usable protein per hectare is important because currently it's not being used. So what is the press cake silage in this process? It's an alternative animal feed for grass. The trials that were done, they replaced 30% of the diet, the grass silage that cows would normally have, with the press cake silage. And it increases the nutrient use efficiency. It reduces methane concentration produced by the cows in their rumen, and it also reduces the nitrogen and the phosphorus that they're excreting in their slurry or dung or their manure. And this all helps to valorize or increase the value of the grass to the farmer. Out of the liquid feed, that's out of the liquid juice that comes out of the grass when it's processed. This liquid juice can be processed further. And one of the products which is produced from this further processing is a high protein feed for monogas, for pigs. And that protein feed is 33.9% protein percent. And in relation to why would you do this, or what's the theory behind it? Instead of buying soya from South America and bringing it to Europe, or Ireland in this case, it's producible at home from a resource that's not being utilized at the moment. But also, when comparing like for like, the protein that is produced from the grass juice uses 1/3 less of land to produce the same amount of protein as Brazilian soya. So it's an increase in efficiency in the production per hectare of protein that you're producing. And in trials that were done using this, where the traditional imported soya was replaced with the high protein pig feed that was produced by the biorefinery, it showed a higher than average daily intake for the animals involved after a 7-day lag, but that's standard when you're doing trials with pigs. They need to change over to the new diet. There was a higher than average daily gain, and it can reduce up to 50% of the soya in their diets. And as well as this extra income source of potential valorization of the grass for the farmers, it's also going to reduce your transport and distance costs. You're not bringing inputs from South America all the way across the Atlantic. You're reducing emissions with transport costs, and you're increasing the farm efficiency and income. they're as part of the side streams from the process. So you've gotten the grass, you've gotten your high fiber solid part, then you've gotten the liquid and you've refined it down further, and you've created a high protein pig feed. Now you've also got more liquid, and that can be used as a bio-based fertilizer, and this is grass whey. And comparing like with if you just fed the cows the grass and you just spread their slurry on the land versus using this bio-based fertilizer where you've gotten all the added benefits, you're going to have an increase in nitrogen, a reduction in the P content, and a slight reduction in the K content, but they're very comparable. But there's I think off the top of it's 25% nitrogen in the grass whey, and it's 15% nitrogen in the slurry, like for like. It depends on what goes into the process to get the exact figures, but I can give you what was done on the trials exactly if you wish. The other thing with this, sorry, I've gone one too far there. On the products that are coming from the biorefinery process, there's also fructo-oligosaccharides, and they're prebiotics that are fed to chickens in their chicken feed, and they're important with regard to the processing in the biorefinery process, because there has been a technical economic analysis done on the biorefinery process. And again, as I said at the start, it's all about scale. This particular biorefinery was mobile. It was processing 2 tons of fresh weight per hour. Analysis shown that a biorefinery processing 8 tons of fresh weight grass per hour, if it's used in conjunction with an anaerobic digester processing some of the byproducts that aren't used, and because anaerobic digestion with the electricity that's generated on site in conjunction with a biorefinery, it can reduce the because 20% of the biorefinery operating expenses is energy costs, which the anaerobic digester can provide. So on the cost analysis, the simplest way to put it together would be, if a biorefinery is to be established and run on purely the basis of producing feed for ruminants and the feed for the pigs, you're going to have a return on investment which is minus 18%. So there's no one going to want to do that. However, if it's run in conjunction with an anaerobic digester and the fructo-oligosaccharides, so the prebiotics for the chickens, are included, and when all of those income streams are included, your return on investment is closer to 13%. So if there's any questions, I'll wrap it up because I'm aware the time is running on. So I'll hand it back to Daniel, and I'd be happy to answer questions. Thank you.
Yeah, thank you so much, John. With that, I would like to open it up to the audience. If there are any remaining questions, feel free to raise your hand, speak up, type in the chat. I would also like to draw your attention that Anna, meanwhile, answered the questions about financial information towards the slurry concentrator in more detail. So you will find more info about OPEX and CAPEX there. But yeah, if there's anything else left, please feel free to type or to raise your hand now. And remember, there's always our community of practice for further questions. You will find it on our website. Also, I will just post a link in the chat for you. You can access it here. Feel free to give it a try. Well, yeah, feel invited. And I think there's nothing else coming up. I don't see anyone typing. So I think just in time we can, yeah. You're welcome, Henry. So just in time, we will wrap this webinar up for today. Thank you all for attending, and we hope to see you in one of the next webinars. Thanks to all the speakers, and have a nice day. Bye-bye.
Thank you. Bye-bye.
Bye.
Thank you.
Bye-bye.